Adobe class. Okay. Today I want to speak and talk about coding in PyCharm. I don't know which page is related to it. Yeah. We talk about Python in our classes, and now this session, we want to continue our discussion about neural network with Python. As you remember, the main code, the skeleton code of neural network is that we must know about the structure of the neural network. For example, how many layers, how many nodes we need, about the initialization of the weighting, and about the input. All of things must be clear for us. Then the first step for the neural network code is initialization, to set the number of input, hidden, and output nodes, and the weighting. And another, after we define these parameters, we must train this neural network and update and according to the some inputs and our target, we must update the weightings. Okay. And finally, we try to access a neural network with the minimum error, or on the other hand, with the best weightings links. Okay. After that, this query is related to test. Query means test. Okay. We must test the defined neural network with new data and evaluate neural network. Okay, we know these things and we talked much about these things and said that how we can update the. Now in Python, we define a class with the name of a neural network, and these three steps: the initialization, the training the neural network, and the evaluation of the neural network would be due. Okay. Step by step, we introduce it. As far as we said, content behavior, and we can make an object with this class. The behavior is common between the objects. The behaviors would be different for each object. Okay, so we expect that in each class we have some function, and we define some function. Okay, in this code, in this book, we will define three functions with initialization, train, and query. Okay. The initialization. As we said before, we must know about the number of input nodes, hidden nodes, and output nodes. And in this example, we will consider three layers, input, hidden, and outputs. Okay? It is like the previous example in the previous chapters. Because of this, the author of this book again consider the previous structure, and with that example we will discuss. Okay, we said that some magic function to underlines a name and again underlines. Okay, and we said that the def is used for the defining a function. Okay. After that, as you see here, you'll see that in parentheses the optional inputs. Okay, and then after that color, it is related to the structure of function and function. Okay, and in this magic function, the first input named self. Okay, and then after that the second, third, and others. Here is the number of input nodes, the number of hidden nodes, and the number of output nodes, and the learning rate. Okay, learning rate is related to the for weights updating. Okay, and why we define self here? Because we want to express, and we want to define, we want to say that we ourselves wanted to fit the desired function. Okay, that in the body of the function we said that self dot I nodes is equal to input nodes. We name set number of nodes in each input, hidden, and output layer. Self dot h nodes is the number of hidden nodes. Self dot o nodes is equal to output nodes, and we define the number of input, hidden, and outputs, not a Python or a previous code. Okay. All students ask a question. The object name is constant. The number of input nodes. No, we can't change it. We can't change it. In this way, I also can see you better. I hope I understand your question. Zahra, do you get it? I understand your... Okay. And self, that's LR is their learning rate. Okay. Then when we have an example after the explanation, we have an example. For example, we said that this neural network with 3, for example, 0.2. Okay, and to call this class don't say self, but we define these inputs of this function. Okay, and pass here is that means this function finish. Okay, for example, as I said, it is related to the previous example. Then all of the nodes of the input, hidden, and output is 3 with the learning rate of 0.3. Okay, and here n is equal to neural network as the name of the class with this input. Here you don't see self, but we define self in this magic function. Okay, I explain all of them, and then after that in PyCharm I will run it. Okay, and then after that, if you remember, we must initialize the weight. Okay, and because here we have 3 layers: input layer and output layer. Okay, input, hidden, and output. Then we have weighting between input and hidden. We called it W, input hidden, with the size of hidden node by input node. Okay, and then also we have weightings between hidden and output. I don't draw this, but we have weightings between hidden and output. Okay, then we have another matrix of weighting W. We called it hidden output with the size of output node by hidden node. And because, for example, in this example, there are 3, this is 3 by 3, and then the matrix of hidden outputs again is 3 by 3. Okay? Oh. Any questions? And for the first initializing the weighting, we use NumPy. NumPy is a library, very common, very famous, very applicable, very usable a library in NumPy. And in NumPy we have a function. For example, one of them is random, and one of the random is rand. Okay, you can help this function in Python. and then you will see it produces the random random numbers. Of course, not completely integer, they are fluid, and the input is rows and columns. Okay, and because as I said because here we need, for example, we need W, I, H with the size of 3 by 3, then the row and column of this function is 3 by 3. And what is the 3? And this 3 is related to the number of hidden, and this 3 is related to the number of input nodes. Okay. And because this function produce between the random numbers between 0 to 1, and we need, for example, between minus 0.5 to plus 0.5. Because of this, we subtracts this function from this number 0 minus 0.5, and then you see the differences between this and this. Because we need more initialized weighting, we performed in this way. Okay, all of them here is positive, and here is some of them is positive, some of them are negative. Okay. And then we need we must initialize this weighting. Then we called self dot again WIH. WIH is related to the matrix of weighting between input and hidden. Is equal to it must be 3 by 3. Okay. Then of course in this example, numpy random rand self dot h nodes. It means the number of hidden nodes, and here the number of input nodes, and then v minus 0.9. I explain why. Then another weighting matrix W between hidden and output. Okay, again we initialized it with rand with the size of output nodes and hidden nodes. And a more complicated, if you want to have a more complicated initializing weighting, then we can use in numpy random, instead of rand, we can use normal. It means that the distribution of this produced random numbers has the distribution Gaussian, has the Gaussian distribution. Okay. Then in the Gaussian, I need two parameters. Okay, the mean and the standard deviation. Okay, And besides, then the size of the matrix WIH must be 3 by 3. Then the mean of this function is Gaussian is 0. Okay, with this standard deviation. Okay, and with each size with this size. Again, for the weighting matrix of W hidden output, the Gaussian distribution with 0 mean, and this is standard deviation with this size. Why explain why details was in the different master for the computer students when they want to defend from their projects. Commonly, usually, they said that, okay, we enter the inputs and we get the outputs. And they didn't know about the details. But we, special for you, because you must write a code and then you must know the details. Because of this, I explain my details. Okay. And the querying the network, it is said that, okay, if we have if we want to test this neural network, okay, the input, we know this from the previous sessions. By the input, by the weight between input and hidden, okay, then it causes the X, the input for the hidden. We called it X, okay. Then in Python, multiplication do but this function again numpy dot matrix W IH input hidden, okay, input hidden is like this, and this is also the input, and it caused the inputs for the hidden here, and then after that it passed through the sigmoid. Do you remember? And it causes the hidden outputs. Then again hidden outputs multiplied by W hidden output, and cause the produces the input of the output layer. Okay, the output of hidden be accessible after the passing through the sigmoid function. Okay, then we need sigmoid. We need sigmoid function. How we make it? In Python, for this activation function, use Skype. Skype is a library of this activation function. Skype.special, okay, and then in Skype special, the sigmoid is expired. If I pronounce it correct, is expired. Okay. Then this Skype spatial expired is related to the sigmoid as a activation function. Sigmoid function, okay, is related to sigmoid function. Okay. Then we have to import this library, and then after that we use this. Okay. But now in our program, we called it self.activation function. Is instead of we define a function as like this. It's the previous structure. We set that for function. We set that okay. We set that def name of a function. For example, I don't know. Activation, active function. Okay, and then input column is that right code, and then pass. Okay. Instead of using this, okay, only in one line, set that the name of this function is lambda, the int is the output. We set that here you can write it return something. Okay, do you remember? We can set that return something. Instead of, we set that this is the input and this is the output. And in one line, only in one line, this is very interesting. In one line, we define this function. And the output of this function will be assigned to self.activation function. Okay? Any questions? Then, if you remember here, we said that after hidden through the sigmoid function. Then here, the input of this x hidden and the output is output of the layer. Here said that, okay, hidden is equal to that function with hidden input. We assign it before. Okay. And here is the summary of all of this. We call that, okay, hidden input numpy dot WIH multiplied by input, and then this hidden must pass through the activation function. Okay, we define this by lambda. Okay, and then this repeated for the output layer. Then final inputs. It means that the input of the output layer. The input of the output layer, WHO, the matrix between hidden and output, multiplied by a hidden output. It means, yeah, like, again, I write it. sorry, right here we set the 3 hidden, 3 output, the matrix of weighting H, here W, hidden output, we have input here, and this input multiplied by this W, and then cause hidden input. We called it X hidden. Okay, we called it X hidden. And then this is passed through the sigmoid function, cause the hidden output of hidden layer. This output of hidden multiplied by this matrix, and then cause the input of this output layer, and then again this pass through the, and then finally we have the final output. Okay, I hope okay. Any questions? Any questions? You must remember the previous sessions about walnut. Also review the name, like always. Okay, then this is a summary. We will review it again after. Okay, now in chart. In the previous sessions, we use Python directly. We use the shelf and interpreter. And in this session, I will PyChart. You must install PyChart. Maybe you know. Download it. This Python professional developers. Download, and then after that install it. Then it is like this. Okay. For define a new project, for example, you can set to file, new project, and then, for example, yeah, so Arachio, courses, advanced algorithm, code, and then in here in code, in, for example, in Python programming, and then in PyChart. Okay, I define I have for example, I have before it for example this test, for example, or I can set that advanced algorithm test create. Here you see that it created, and then go to project, and then after that right click on the AA test, new Python file, then you can create a new Python. For example, I don't know, try and then play. Okay, and in this book, Rashid uploaded the link here. Okay, the complete neural network code. Okay. Then you can this here, and in the previous have this. Okay, I have, or you can also go open. I don't want to use the previous. Because I want to produce myself for you. Where is it? Courses. Oh, here is algorithm, codes, Python, PyCharm. I have this here. Okay. Okay, we open. Okay. And then if we you can copy, you can sign it and then download it. I don't know, but the simple is that I could. Okay. And then paste it. Okay. Okay. Question? Any question? Okay. Today you are too silent. And then we want to in my system, I need this. You see that it runs, but we, of course, okay, now it finished. Okay, it finished, but I cannot see here. For example, I must. I think this is the bad features or worst feature of Python, because if you run it in your system, I have to. Sorry, I have to. Like this, and so here is n. You see that? I think because of my RAM, I have some problem. Oh, sample, and I run it n. Please n. I type in, but it doesn't get. Please wait. It's okay. And then n. Oh. It happens. I copy and paste it, maybe it work. Okay. And then I said that print sample. Okay, and now I run it again. Zahra has said that about the define something. Here we ourselves define it, and then now we want to see the query here, and then run it, and then now you can here you can see the output of this class. We make an object from the neural network. We called a query. Query was the function of this neural network. And then we said that, okay, print sample. You see here. Okay. And now the code. As you see, import NumPy, the famous library, import Skype special. It is related to the activation function. And it is usual that, I don't know why Rashid called it, it is usual that we name of the class with capital letters. But here he write with neural, okay, not capital. And then define the initializer. I said that self, the number of input, hidden output of learning rate. All of them are here. It is related to the matrix of W, learning rate, activation function, and then pass and train. Here we don't explain about the train. I will explain you. And then you said that, okay, the query means test. Get the input list is our input, and then by this NumPy array, the input list, okay, with two-dimensional, and transpose it, and then that the to explain WIA multiplied by input, and then after passing through activation, then and passing through input layer, finally we have final outputs. Okay. And about the training, and here an example. Okay. An example about the training. One of the function of this class is train. Train must be input list and target list. The one neural network we need. Again, by using NumPy array, we convert the input and target list to the array. And then here, these 4 lines produces the final outputs. Okay, and then after that we must calculate the error. And we know that target might produce error. Okay, and if you remember, if we have 3 layers, For example, here if we have 3 layers, we calculate error. For example, error out 1, error out 2, error output 3. Okay, we backpropagate this error to the previous layers. How we backpropagate it? According to the weightings. Do you remember? Said that okay. For example, this weighting is larger than this error. Sorry. Then the effect of this node is much larger than this node. Then according to this weighting and this, for example, weighting, we backpropagate this to error to the previous layer. I hope you remember it. Okay. Then here it tries to backpropagate the previous one. Okay. And then after the backpropagate, we must to update the weighting matrix, and we have the code here. I must remind you here. Here is the error of hidden, okay? And then for updating the, we said that, discussed it before, finally we said that, okay, it produces by this equation. OG is the output of a layer J, a node J. OK is the related the next layer, and error is the error of the next layer. Alpha is a learning rate. Okay. Then according to this, we must, okay. It is better that okay, according to this, we said that, okay, alpha self-learning rate multiplied by sigmoid OK multiplied by 1 minus sigmoid OK. Sigmoid OK, do you remember we called it final output. Here and here is the final output. At this line, we want to update the W, the weighting between hidden and output. Okay. Then the next layer of the hidden is output layer. Then the sigmoid OK here in this line is final output. Okay, is a final. Is a final output. Is a sigmoid OK. And again here is sigmoid OK. Okay. And then NumPy transpose hidden output. we said that it is related to the output of the current layer is here. We transpose it. Okay. And another thing, if you remember, we said that the order operation, okay? We said that the first thing is parentheses. Said that, okay, here is this, and then this parentheses. Sorry, I must use another color. Here we have these parentheses. Okay. Then numpy dot means that this pink multiplied by this yellow. Okay, and the pink is this. Output here. Output layer here. It is related to this pink. And this is learning. And this is output final. The output of hidden. Okay, and what is this? What is this? It means that I said that R plus equal 3. It means that R is equal to R plus 3. Then here we must to update the weighting of WHO. It means that old WHO, we said that these things, I called it A plus, of course, here is new. Of course, no. Also, it is better that I said that. Okay, it is old, and then WHO new. Then after that, WHO new is equal to A plus WHO old. Then, because of this, we can use this plus equal. Okay? And then, for update the weights for the links between the input and hidden layer, we must backpropagate the error of hidden to the input layer. We'll repeat all of this for the W matrix of weighting of input hidden layer. Okay? Any questions? Okay. Hala Hassan said that from in the book. You can in the book. The link is in the book. Okay. The book, the code, the link. You can download it. Okay. And then it finished. We update the weighting. Finished. I think it is enough for this session. In the next session, I will record it for the. Of course, the code are also in the book too, and here is the link. In the next session, I said that how to download the MNIST dataset is a handwriting dataset, and then by this, only by this neural network class, we can train and test this neural network and see the results. If you don't have any questions, we finish this session. Okay. Some of you sent me some messages in Telegram. I said at the first time of this class, I said that I will see it soon in this weekend. Okay. No questions? Okay. Thanks for your time, and bye. You're welcome. Bye. Goodbye.